Understanding the scenario. Welcome to the channel. Please subscribe. I produce videos daily on various cloud topics. Welcome. Let's explore how to monitor and alert on dedicated interconnect errors in Google Cloud. This question tests your understanding of cloud monitoring, alerting mechanisms, and the difference between cloud monitoring and cloud logging. The scenario is straightforward. We have an on-premises network connected to Google Cloud via dedicated interconnect. When errors on this connection exceed a threshold, we need to notify a network engineer via both email and Slack. The key here is understanding which Google Cloud services are involved and what components are not needed for this solution. Dedicated Interconnect Overview. Before diving into the monitoring solution, let me explain Dedicated Interconnect. It's a physical connection between your on-premises network and Google's network, providing high bandwidth, low latency connectivity. Like any network connection, it can experience errors, packet loss, transmission errors, or link failures. Google Cloud automatically collects metrics about these errors, which we can use for monitoring. The important point is that these metrics are already available in cloud monitoring. We don't need to create them ourselves. Cloud monitoring versus cloud logging. This is crucial to understand. Cloud monitoring and cloud logging serve different purposes. Cloud monitoring deals with metrics, numeric values over time like error counts, latency, and throughput. It's where we create alert policies based on these metrics. Cloud logging deals with log entries, text-based event records. While logs can be converted to metrics, for dedicated interconnect error monitoring, we work directly with the metrics in cloud monitoring. This distinction is key to identifying the correct answer. The complete solution flow. Let me walk you through how this alerting system works end to end. First, dedicated interconnect automatically reports metrics to cloud monitoring. These include error counts, packet loss, and other network statistics. We create an alert policy in cloud monitoring that watches these metrics. When errors exceed our threshold, the alert triggers. The alert then sends notifications through configured channels, in this case, both email and Slack. Each channel needs to be properly configured with the right destinations. Option 1. Slack channel configuration. The first option suggests updating notification channels to post to Slack. This is part of the solution. Let me explain the gcloud command for creating a Slack channel. We use gcloud alpha monitoring channels create because the notification channels API is still in alpha. The type equals Slack parameter specifies we want a Slack integration. The critical part is channel labels equals URL equals your underscore webhook underscore URL. This webhook URL comes from your Slack workspace when you add an incoming webhook app. Each notification type has different required labels. Slack needs URL, email needs email underscore address, SMS needs phone number. Once created, the channel gets a unique ID like projects, my project, notification channels followed by channel number that we'll use when creating alert policies. Option 2. Alert policy in cloud monitoring. Creating an alert policy in cloud monitoring is absolutely essential. This is part of the solution. The gcloud command for creating alert policies is complex, so let me break it down. We use gcloud alpha monitoring policies create with several key parameters. The notification channels parameter takes comma-separated channel IDs. You get these IDs by running gcloud alpha monitoring channels list format equals value name. The format flag extracts just the ID field from the output. The most complex part is the condition parameter. It's a JSON object that defines when to trigger the alert. The filter field uses monitoring query language to select our metric. In this case, interconnect.googleapps.com/received_errors. The comparison is comparison_GT. Greater than threshold value is our error count limit. And duration ensures the condition persists for 60 seconds before alerting to avoid false positives. The aggregation section is crucial. It defines how to process the time series data. We use align_rate to calculate errors per second over 60-second windows. Option 3. Alert policy in cloud logging. Here's our answer. Creating an alert policy in cloud logging is not part of the solution. This is a fundamental limitation. Cloud logging simply doesn't have the capability to create alert policies. If you try to run something like gcloud logging policies create, you'll get an error because this command doesn't exist. What confuses people is that cloud logging can create metrics using gcloud logging metrics create. These log-based metrics then appear in cloud monitoring, where you can create alerts on them. But the alert policy itself? That's always created in cloud monitoring using gcloud alpha monitoring policies create. Think of it this way. Cloud logging is like a data source that can feed metrics to cloud monitoring. Cloud monitoring is the alerting engine that watches those metrics and triggers notifications. They work together, but each has distinct responsibilities. Option 4. Log-based metrics. Creating a log-based metric might seem unnecessary, but it could be part of the solution depending on the implementation. If you need to create a log-based metric, you'd use gcloud logging metrics create. The command takes a filter parameter that uses logging query language to select specific log entries. For example, resource type equals interconnect and severity equals error would capture error logs from the interconnect. The value extractor parameter is interesting. It extracts numeric values from logs using a path expression like extract JS on payload error_count. This assumes your logs contain structured data with an error_count field. However, for dedicated interconnect, the built-in metric interconnect.googleapps.com/received_errors single quote is usually sufficient. Creating log-based metrics adds complexity and latency. The metric only updates when new matching logs arrive, whereas built-in metrics update in near real time. Option 5. Email configuration. Updating notification channels with email addresses is definitely part of the solution. Creating an email channel is simpler than Slack. The command gcloud alpha monitoring channels create uses type equals email and channel labels equals email_address equals engineer@company.com. Notice how the required label changes based on the channel type. An important detail. When you create an email channel, Google sends a verification email to that address. The recipient must click the verification link before the channel becomes active. You can check the verification status using gcloud alpha monitoring channels described channel_ID. Pro tip. You can create multiple email channels for different team members or distribution lists. When creating the alert policy, include all relevant channel IDs in the notification channels parameter, separated by commas. Implementation steps. Now let me walk you through the complete implementation with detailed command explanations. First, we create notification channels. The alpha in the command is required because the notification channel's API is still in alpha stage. Each channel type requires specific labels. Email needs email_address, Slack needs URL. For the webhook, SMS would need number. Next, we need to get the channel IDs. The command gcloud alpha monitoring channels list format equals value name is clever. The format flag extracts just the name field, which is the full channel ID, from each channel. We use tr to convert new lines to commas, creating a comma-separated list for the alert policy. The alert policy creation is the most complex. The condition is a JSON object where filter uses monitoring query language, MQL, to select our metric. The backslashes before quotes are escape characters needed in the shell. Comparison_GT means greater than, and align_rate converts our error count to errors per second. Finally, we can verify everything with gcloud alpha monitoring channels verify, which sends a test notification. Very useful for confirming Slack webhooks and email addresses work correctly. Monitoring best practices and command tips. Let me share some best practices for production monitoring setups and useful gcloud command tips. First, always use the format flag effectively. For example, gcloud alpha monitoring policies list format equals table, display name, conditions, 0, threshold. Enabled creates a nice table showing policy names, thresholds, and whether they're enabled. The format flag is powerful. You can extract nested fields using dot notation. For debugging, use log HTTP to see the actual API calls being made. This helps understand what the gcloud commands are doing behind the scenes. When creating complex conditions, I recommend building them in the Cloud Console first, then using gcloud alpha monitoring policies describe policy_ID format equals JSON to see the exact JSON structure. You can then adapt this for your gcloud commands. For production systems, always version control your monitoring configuration. Export your policies with gcloud alpha monitoring policies list format equals export greater than policies YAML and commit them to Git. This allows you to track changes and quickly recreate your monitoring setup in other projects. Summary and key takeaways. Let's wrap up with the key points. The correct answer is that creating an alert policy in cloud logging is not part of the solution. Remember, cloud logging handles logs, cloud monitoring handles metrics and alerts. Even log-based alerts are created in cloud monitoring, not cloud logging. For this scenario, you need a metric, either built-in or log-based, notification channels, email and Slack, and an alert policy in cloud monitoring. That's it. Thank you for your attention. Please subscribe to the channel.